force between two parallel current carrying conductors. Students, in the earlier video you know force on a current carrying conductor when placed in a uniform magnetic field, that is your F is equal to I L vector cross B vector. That means B is the uniform magnetic field in which a current carrying conductor of length L with current I is placed. So what happens? A force is experienced, that is F is equal to I L cross B. Now you consider two current carrying conductors, infinite long straight conductors. It carries current I1, it carries current I2. Distance separation is R. Between these two, your distance separation is R. So we have to find force between these two conductors. So to find out force, magnetic field is needed. So how to find out magnetic field? You know, a current carrying conductor produces magnetic field around it. Suppose if I consider this is a current carrying conductor, a magnetic field is produced around this. So I mean, for this conductor, magnetic field is here and also here. Similarly, for that conductor, magnetic field is here and in that side. Now, for conductor carrying current I1, magnetic field here is inward magnetic field B1. For this conductor, magnetic field is B1, and this is inward. By applying your screw rule, you get inward magnetic field. You just forget this now. So in this inward magnetic field, this current carrying conductor is placed. So what will happen? A force is experienced. So first we have to find out what is B1, and this is B1 is equal to mu naught I1 divided by 2 pi r. This is in inward direction because this B1 is for current carrying conductor I1 and at a distance r. So B1 is for this. Now in this magnetic field B1, this conductor is placed. So how much force is experienced? So force per unit length, I will write force per unit length, that is equal to F2. How much? That is I2 B1 sin 90 degree. You know this formula, what? Force is equal to ILB sin theta. And in this case, theta is 90 degree. How? Current is in this direction. Magnetic field is inward, means towards the wall. So angle is 90. That's why I put 90. And I have taken force per unit length as F2. I will force by this length as F2. So F2 is what? This is not force. This is force per unit length. So I2 B1 sine 90. That is I2 B1 is what? This one. Mu naught I1 by 2 pi r sine 90 is 1. So you get force per unit length F2 is equal to this one. So how to find out the direction of that force F2? So to know the direction of force, you have to apply Fleming's left hand rule. You see, this is the central finger, direction of current. This is your forefinger, direction of magnetic field. And this thumb gives you direction of force. So now you apply, magnetic field is inward. Inward, current is towards this. So thumb is towards left. So when you apply this, thumb is towards left. I mean this force is towards left. So force on this conductor due to magnetic field B1 is F2, which is towards left. So this is the direction of force. Now students, we take for reverse way, or in a reverse way we consider, but so now you see, so here is the conductor, that is first conductor I1. Now for this conductor, what is the magnetic field here? This is your B2. For this conductor, magnetic field is B2 and the direction is outward. This is the direction of magnetic field B2. So what is B2? B2 is mu naught I2 divided by 2 pi r, because from this distance is r. So what is the direction? This is outward, already know. Now you forget this. So now in this B2 magnetic field, this current carrying conductor I1 is placed. So when a current carrying conductor is placed in a magnetic field, a force is experienced. So force per unit length. One questions, why we take force per unit length? Because this is infinite long conductor. That's why per unit length is taken. So this force per unit length is now F1, which is I1 into B2, because current is I1, magnetic field is B2. That's why F1 is equal to I1 into B2. That is what I1. What is B2? Mu naught I2 by 2 pi r. So students, you see, force per unit length F2 and force per unit length F1, they have same magnitude. That is mu naught I1 I2 by 2 pi r. Also in that case, same has come. What is the direction of this force? Again you apply Fleming's left hand rule. Magnetic field outward means towards you. Current is upward like this. I rotate my hand like this. So you see the thumb is in this direction. You just see. So force is in that direction. That means towards right. So students, what you see, if I make both conductors like that I forget this. Now this is I1, this is I2, this is F2, this is F1. So these two forces have same magnitude but acting towards each other means they attract. I mean these two conductors attract each other. So what conclusion will you draw? When two parallel conductors carry current in same direction, they attract each other. But if students, I change the direction, suppose if this is the case, you see, suppose current is in this direction and in that direction. I mean both are in opposite direction. So what happens? Same case. Similarly, you can find out this is I1, this is I2. This conductor produces magnetic field inward, that is B1. Now in this inward magnetic field, current carrying conductor is placed. So applying this Fleming's left hand rule, you will get the force. So you see magnetic field is inward, current is downward, just I rotate. So my thumb is towards right. So that means force per unit length, that is F2, is this. Students, magnitudes are same. B1 is same as that of the earlier one. Also F2 is same as that of the earlier one because this is I1, this is I2, and also distance is same. Only direction is different. Otherwise, other things are same. Similarly, for this current carrying conductor, magnetic field is B2, but this is inward direction. Now in this inward magnetic field, a current carrying conductor I1 is placed. Similarly, you apply. So force is towards right, that is F1. So what you see? These two forces are away from each other, means they repel. So what conclusion will you draw? When two current carrying conductors are in opposite, anti-parallel, or you say opposite direction, then they repel each other. But very important, how to know the direction. Already in the previous video I have shown, still I am saying, suppose here is a conductor. If current is in this direction, point is here, means you join this. This is known as R vector, like this. So if rotation is clockwise, current is in this direction, you start to rotate like that. Since it is clockwise, this is inward. I mean for clockwise, B is inward. This is the symbol. Cross is the symbol for inward. Similarly, if the point is here, you rotation like this from this. So this is anti-clockwise, means outward. This is the symbol for outward magnetic field. So one is inward, another is outward. So based on this, you can find out force. First to find magnetic field direction, then force, you apply Fleming's left hand rule. According to the magnetic field and current, your hand will be rotated, and the thumb gives the direction of force.